Hello, this is the Reading Week video. I'm not going to be going through slides this week since we don't have any work. There's no topics, but I hope you have fun with the Reading Week work. Of course, the large data set, that's going to be very interesting. But anyway, I'm just going to be going through the 3 AS papers today, and we're going to start with the 2022 one. So, go to the first question. Just an integration, you just have to simplify the powers down and then do all the stuff, the integration stuff, add 1 to the power, divide by the new power, and then remember the plus c. That's the last mark. Question 2, we have some factor theorem. So for part A, you just substitute -3 in. That gives you 0. I'm not sure if you even have to I rep x instead of -3, but I'm not even sure if you have to really show. You could just assume that if you substitute -3 and it's 0, you don't really have to check out your calculator. Next, we just do the division that it's asking us to do. So you just do the division, do whatever method you want to do, and then factorize it out. So that's our quadratic. And part C showed that it only has one real root. Well, you get the quadratic that you got from that. You know that x equals 3, which is one root. X equals -3, sorry. And for the quadratic that you factorize out, you can use the discriminant to show that the quadratic has no roots because the discriminant is less than 0. Therefore, the cubic has one total root because this is one of the roots, and then this quadratic doesn't have any roots. And then this is a classic question. They like doing this, especially on AS papers, where they shift the graph over and tell you to find the new root, because if the root before was -3, 0, if you move that 5 to the right, it's just going to be 2, 0. And that is the answer. Question 3. We have some vectors going on here. So you're finding QR. So I probably should have drawn this, but you just go from 3i to 13i, you get 10i. To go from 5j to -15j, it's -20j. Find mod QR, that's just the distance, so you just do Pythagoras. I know we haven't done vectors yet, so this is kind of a useless question in sort of sense, but you can kind of figure this out. I and j are just unit vectors, where I is 1, 0 and j is 0, 1, so in column vector form, so you can kind of figure this out. And then the point S lies on this line segment, where you know that you can find that QS is this, because QS to SR is that. So you can use this ratio. You can just multiply this by 3/5, and then to find PS, you just go from P, so going from 3J to 30. Yeah, you just go from P to S. As you know what QS is, so now you can find PS, and that just gives you the answer, really. Yeah, sorry, yeah, again, we haven't done vectors, so don't really worry about this question. But yeah, let's move on. Alright, so we have some GCSE style trick here. You just use cosine rule. You can use multiple things here probably, but you probably use sine rule as well. But I use cosine rule, and you just get the quadratic that's asking you to get. Next question, find the value of x. Just use, well, you can pretend to use quadratic formula and then just use a calculator, and it can't be negative because otherwise the sign meant to be negative. And find the value of theta. Here I just use sine rule, and it gives you this answer. Alright, next question, we have a log relationship. We haven't done this, but you can kind of figure this one out. So what I did is I raised them both to base power 10. So the 10 log base 10 a is going to cancel out, so it's just a, and then it's going to be 10 to the 0.5 times 10 to the 0.03t. So 10 to the 0.5 is just that, 3.162, and then 10 to the 0.03t is just 10 to the 0.03 to the t, which means that you just do 10 to the 0.03 is 1.072, and then that's to the t. And that gives you the relationship that you wanted to. Then they like these questions with interpret these constants, so it just means what does it actually mean in real life in the model. So you know that it's T is the number of weeks after massive algae was first recorded, and then A is the mass of algae. So you just say that I is the initial mass, And yeah, and you can interpret Q as well, which is like the base, the base amount that it increases per year. I put multiplier, but that was wrong. And then part C, you have, this is just, they like these questions where you just substitute stuff into the model. So this time you just substitute you let t equals 8 because it asks you find when t equals 8, and you round to the 0.5 kilograms, and then find the number of weeks. When it reaches 4 kilograms, you just set a to 4, and then you solve using logs. And then state why the model might not be realistic. Well, you just say that it's not going to increase at this rate forever, because otherwise there'd be like trillions or like quadrillions of algae, which obviously isn't realistic, or they'll die out at some point. It's anything like that will give you the mark. Next question, I think we have some binomial expansion. Yep. So the first one is just find the first 4 terms. So it's just like simple binomial expansion stuff, and then you expand, you will choose functions on your calculator. Then next part, find the coefficient of x squared, which means that for this one you have to do there's 2 different terms you have to do, because this one doesn't really make much sense, because, or it's not, no, it doesn't make sense, it's difficult, where that you have to, there's a fraction here where there's 2 different terms per fraction. So let's say you use the single x term here, it'll give you an x squared term, it'll give you an x term, and just a term with nothing, because you're doing x divided by 2x, which means you need, because I got this wrong, but I think you need to you're finding the x squared term, which means you either need, because there's for each term that you use here, there's 2 different terms for this left fraction here. So what you need to do is you need to find the 2 terms where that works. So it's the x squared term and the x cubed term, and you expand both of these. So you do the x cubed term and the x squared term of this one here, of this binomial of x, and then you simplify them down. You only use the terms of x squared, you don't use the other terms you get from it, if that makes any sense. Next question we have, this is a much easier question. We're just factorizing, this is just difference of 2 squares. Then next question we have to sketch it, which is just showing the roots, and there's not a y-intercept to show because that is the y-intercept 0, 0. And then find, it says the line where y equals k intersects. Oh yeah, sorry. So this question is saying that there's a horizontal line that intersects this graph, and they intersect at 3 distinct points, which means that it has to be from here, where my cursor is, to down here, which basically means that it needs to be above or below, it needs to be in between the 2 stationary points. That's basically what that means, to intersect 3 times, because otherwise it will intersect once. So if it's on the stationary point, it will intersect twice. But it needs to be in between the stationary points. So I found the stationary points by taking the derivative and then substituting it back in. Those are the 2 stationary points, and these are the y coordinates. So this is negative 6√3. This is positive 6√3 on the y coordinates, and it's not greater less than or equal to. You have to put it in set notation. It's not less than or equal to, because otherwise it would intersect twice if it was on the stationary point. And then you just write it out in set notation. I don't think you have to write like the set of values of k, or the set of values when you're doing set notation, but I don't know, I just do it to be safe. Right, next question, we have another model question. They always like writing like, oh, given that the initial air pressure is, or the initial whatever is this, and it's just you set t to 0 because the model has t in it. So so here you just set t to 0, and it just gives you 1.4 because e to the 0 is 1, and then you just get k equals 0.8. For the next question, you have to substitute value in, just like the last question, for time taken for the air pressure to fall to 1, which means that you just substitute 1 into p and then solve. You use learn, and then that gives you the answer. Next question, we have to find the rate, which means that we have to take the derivative, which we haven't explicitly done. It was in the learning pack when we did E, but we didn't actually really cover it in class that much. So, or depending on what class you're in. But when you're taking the derivative of e, you keep it the same, because obviously e to the x is just, the derivative of e to the x is just e to the x, but when you have a constant, you keep the thing the same, you just multiply it by whatever's here. So this is the derivative of 1.4 e to the 0.5 negative 0.5t is just negative 0.7 e to the negative 0.5t. So you just multiply by what's there, and then keep the e part the same. And then here you're just finding where the rate is 2 minutes, so you just substitute 2 into t after you take the derivative, and then that gives you the answer. Right, next question, we have one of these log questions where it says, like, given that it gives you another variable and then tells you to write this in terms of that variable. So this is just p minus 2 because it's log base 3x minus log base 3 of 9, which is just 2. And then this one is just half p because root x is x to the half, you move the half and you get half p. And then when it gives you an equation like this, I would always use the substitutions that they give you. So, or depending on what the question is, but here it's definitely better to use the substitution. So I just substituted 2p into this, and so I substituted everything in, simplified down, and then you get the answer of 1/9. Next question. So here we have, this is a 10-mark question, so you can spend a lot of time on it. So firstly, we're showing that this tangent has this equation, and because it's a tangent, we should take the derivative here. So we're taking the derivative, find this. I substituted this x coordinate back in just so I can use it for later. You know it's when x is 4, so you substitute 4 into the derivative. That gives you the gradient. Solve for the plus c. You get this, and then you just multiply out, get the line, and it's just like normal coordinate geometry after you substitute the derivative in. Then you use this line to find this area with integration. So what I did is that I used this triangle here, so where this is P, this is 2, 0, which is where the line intersects the x-axis. And then down here is just the points, so like down here. And then I found the area of this triangle, so I said that this is 13/3 because the y-coordinate of P is 13/3. So this length down here is just 13/3. This is just 2 because this coordinate is 2, 0. This coordinate is 4, 0. So you just do this and it's 2. Then you multiply, you find the area, so 13/3 times 2/2, so it's just 13/3. And then you do the integral from 0 to P minus the triangle to find R. And then that will give you this answer. Right, next question, we have some circles. This is pretty easy stuff. So from this, you complete the square, you can kind of tell. So I just subtracted the stuff in my head and it gives you -9. And then you move it to the other side. So you can see that the radius is 3. You actually don't, for this next part, you actually don't need the full equation of the circle. So I didn't really simplify. You don't actually need the equation of the circle. I kind of just, you can see that the center is 5, 4 from just kind of looking at it. And then I didn't really simplify it because you can just kind of tell that the radius is 3 when you add these numbers together. For the next question, you have to find the shortest distance between C and L. So what I did is that, so firstly I rearranged this line to just give me what the line actually was, and then I found the perpendicular, and what you do is you just say the shortest distance between C and L is, what the hell have I done here? Anyway, the shortest distance between C and L is just the perpendicular of L to the radius minus the radius. So it's like from here to the center, then you use the center to find the equation of the line. So what I did here, so I said the perpendicular gradient is 2, and then I substituted the center into here. Yeah, I substituted the center 5, 4 into here, got the line, got all this stuff, and then yeah, I don't really know what I was doing here. I used some like weird further math formula, but you really don't need to do that. All you have to do here is say that the radius is 3, and you get the coordinate where the two lines intersect, and the coordinates of the center. Find the distance between them, and then take away 3, which is the radius. So ignore what I did here. I don't really know what I was doing. But yeah, you can see here, yeah, 19 root 5 over 5 minus 3. So, because you have the coordinates where they intersect, which I found here. X is 1.5, y equals negative 3.6. These are the coordinates of intersection of L, and then the perpendicular of L. And then you use those coordinates, and you find the distance between them and the centre, and then take away the radius, and that will give you the shortest distance. Because you're finding where it touches the circle, the circumference, you're not finding where it gets to the radius. Alright, next question. Oh yeah, this question is very, very high mark, because you have to do some... They tried to make it optimization interesting, but it just made it kind of more annoying. So, firstly, they give you... you just ignore this cost thing at the start. You just do the normal optimization stuff. So you have h equals... So you do pi r squared h equal to the volume equals 355, because it says the capacity, which just means volume. You can see from the units that it's volume. Then for the surface area, it's just... this is the surface area of a cylinder. And... yeah, and then you substitute this into h, do your normal stuff. So this is your equation for S, but it says for the circular base, for the circular base, and the curved side costs this much per centimetre squared, and then just the circular top costs this much, which means that you have to split this 2 pi r squared into pi r squared plus pi r squared, because that's what the bottom and the top, because they both cost separate amounts. You multiply one of them by 0.04, one of them by 0.09, and then you multiply the curved side bit, which is, you know it's the curved side because this is where you substituted in h, that's how you find the curved side of the cylinder. You substitute that into h, substitute 0.04 into that, because you just add 0.04 to it, and then multiply. Sorry, you don't add 0.04, you just multiply it by 0.04, because it's 0.04 pence per centimetre cubed, and you just get, and then you just simplify a bit, and it gives you this. It's a bit complicated because they split the side of the cylinder into the top face and the bottom face, so you have to do different things. So you just split the 2 pi r squared into the 2 different pi r squareds that you get to find the surface area of the cylinder, if that makes any sense. Then the rest of the question is really easy. You don't even really need to understand the first part of the question. You don't need to understand the first part of the question to get the next 3 parts. And it also gives you this. So if you don't know how to do this, you can get these other marks easily. So firstly, you just take the derivative as usual, set it to 0, find r, derivative, derive it again, show that it's greater than 0, show that it's a minimum, and then you substitute it back into this equation here, get c, and that's the answer for B, C, and D. Next question. So we have some trig. We have this first trig question. For this question, I just said that I just turned the tan into sine of a cos, and then to combine the fractions, you get this. Because you already have the same denominator. Sorry. So you get this fraction here. This fraction kind of looks like this fraction, if you think about it. So, but you don't have, you need the sine, you need a 1 minus sine theta on the denominator, so you don't really know how you're supposed to get that. So what I did is I just multiplied by 1 minus sine theta, and that works well because it's a difference of 2 squares on the numerator. So you get 1 minus sine squared on the denominator, and so you get 1 minus sine squared on the numerator, and then cos bracket 1 minus sine on the denominator. And then next thing you get, you don't actually have to expand this bracket because the causes will cancel out, and then you just end up with cos over 1 minus sine, which is what they're asking for. Next question that you have, they just turned it into double angles, so you can just use what it's asking. So it's just you turn this into what you proved earlier, so it's cos 2x over 1 minus sine 2x. You do all the stuff, you combine everything, divide by cos. It says that yeah, that's fine. You can divide by cos because cos isn't 0. Yeah, given that cos 2x isn't 0, so it basically is asking you to divide by cos at this point. Then you just get 3 sine 2x equals 2, divide by 3 sine 2x equals 2, divide by 3, and then you expand the range, and then find your answers. Right, next question. So this is the last question of this paper. We have some proof here. This, I completely overcomplicated this. So I think you can just prove this by deduction. But what I did is said that this is 3 consecutive integers. I think what you're supposed to say is you're supposed to say if one of... Because there's 3 consecutive numbers here, so either 2 of them are odd or 2 of them are even. If it's odd times even, then that's just even times even, which must be divisible by 6, and then if it's even times odd, then it also must be divisible by 6, or something like that. But I did a more thorough proof here, so I did... I factorized this. I said if n is odd, then you create the separate variable here. I did 2m minus 1, not 2m plus 1, because otherwise it would be 2m plus 1, 2m plus 2, 2m plus 3, which takes way longer to expand. So it just becomes the difference of 2 squares, and then you get that it factorizes out. And you say that because this is... It's already a multiple of 3 because 3 consecutive numbers must be a multiple of 3, and we also know it's a multiple of 2, therefore it's a multiple of 6. And then for the even one, you do the same thing. You prove that it's even by factorizing 4 out, and then you say it's a multiple of 3 because it's 3 consecutive integers, and then therefore it will say that it's a multiple of 6. And then because it's a multiple of 6 for both cases, it must be a multiple of 6 for all cases. You could do this multiple different ways. It's 3 marks, and especially if you're at the end of the paper and you need time, then it's probably not very time efficient to do this. But anyway, that's the end of the paper. So let's go on to 2023 paper now. My voice is already giving in, but we'll try. First question. I might have to go a bit faster for the first few questions because they're quite easy. Find dy by dx, find self-explanatory. Find where it's decreasing, set it to less than 0, solve the quadratic inequality, you get this answer. Next question, use this substitution. This is kind of just what I already do anyway for most of the time. This is kind of what you do anyway, kind of in your head when you're doing these questions. So you substitute, get this a hidden quadratic, obviously. It kind of tells you what to do. I don't know how this is 4 marks, but anyway. Then you solve, you say that this isn't a real solution, and that is your answer, because you can't say that u is a negative number if it's the root of something, because otherwise u would not be... If u is negative 5 over 2 and x is 25 over 4, that doesn't work because u would have to be positive, so that's not a correct solution. Next, was that it? That was it, yeah. Next question, we have some bearings, going back to GCSE here. And it gives you this entire angle, and then it gives you this angle. I was wondering why it gave you 2 different angles. It's because you need to subtract the 2 angles from each other to get the angle that you want, and then it's easy from there. You just use cosine rule. And then part B, it asks you to say that the answer, so this distance from A to B here, isn't accurate, because you just say that they can't take an exact straight line, otherwise that's not realistic. You have to take like different paths. Because it's 3 phone masts, so it's going to be in like some city that you can't just take a straight line. Next question, this is a weird question. It gives you a lot of space to sketch the graph. You just sketch the graph here. It's really not that interesting. You sketch the asymptotes just because I was careful with it. Then this question, you have to if you sketch this out, you've realised that it's either if x is greater than or equal to 8, or if x is less than 0, because that's just how reciprocal graphs are. You can't just multiply, but you can multiply by x to find one of the solutions, but you have to just, by deduction, see that it can be less than 0 as well. And it can't be less than or equal to 0 because reciprocal graphs can't equal 0, because otherwise it's dividing by 0. Next question. This is a weird question because they're asking... when I initially saw this question, I thought you could rearrange for y and then solve it, do an integral in dy instead of dx. But it's not a graph you can really do that, because you'd have to use a square root, which turns into a plus or minus, which kind of makes things a lot more complicated. So what I just did, I just found this entire rectangle here, so you can find the coordinates of this point. I just set y to 23, because it gives you this coordinate. Find the x coordinate, find the area of the rectangle, so 23. So this y area is 23, and then this is root 5 on the x-axis. Terrible scale, but anyway. and you just do the area of the rectangle, take away the integral. You see I messed up this integral here because I plus 3 instead of minus 3 root 5. So this answer's wrong, but it's literally just expanding a negative out and doing this calculation. So, and also it's in the mark scheme. I'm not here to tell you the answers, I'm telling you how to get the answers. Next question. Find the center. Well, you don't even need to fully do this here. You just need to say that it's half the x value. It's the negative of half the x value and the negative of half the y value, because that's what you do when you're completing the square. And then, given that it does not cut the x-axis, find the possible values for k. So what this kind of means is that if you think about a circle on a graph, it has to be either... the thing that I missed out actually is that k can also be less than 0, but no, not less than 0. There's another value of k that I didn't really think about here. But to find the first value of k, you have to substitute. It doesn't cut the x-axis. This just means that y is 0. When you touch the x-axis, that's when y is 0. So you just substitute y equals 0 in, get a quadratic like this, and you do the discriminant, because you know that it doesn't. There's no solutions to this quadratic, because it says that it does not touch the x-axis. So you find one of the values of k, and then I assume for the other value of k, you just kind of look at it on the graph. Because I should have drawn out a graph here, and what the circle actually looks like. So you can deduce the other value of k. But anyway, let's go to the next question. We have a linear model here. Haven't seen one of these in a while. It just gives you two coordinates, tells you to find the linear model, which is simple coordinate geometry and simultaneous equations. Get all these. I'm not going to explain how to do linear simultaneous equations. Then you have to find according to the model. You just substitute the values in. So the initial amount of fuel is 50, because that's just a plus c, and then the distance they travelled on the journey. That just means that the total distance in the journey is when the there's 0 litres in the fuel tank, because that's when the journey's over. So you just set it to 0. You set v to 0, and then you solve. It does say, it says evaluate the model. You just say that 400 isn't very close to 320, so therefore the model isn't accurate. Next question. At first I thought it was asking you to find this area, so I was quite worried about this, but it's just asking you to define the area. And so what you have to do, so you have to say, because you know that it goes through 0, 0, there's no plus c, so it's just y equals ax squared plus bx. And there's a lot of things that you have here, so you can, and you also know that this line is y equals mx plus 60, because it gives you the y-intercept. So firstly, you can say that this point is on the line, 1080, so you substitute the point in, get m equals 2, and then this is the equation on the line. And then for the quadratic, you can substitute the roots in, so you can say that when y is 0, x is 6, and same with 1080, you can substitute that point in, and then you solve the simultaneous equations, get the values, and you get the stuff here. So I think I did one of the signs wrong here. It definitely is what I think it's y is less than this quadratic, and y is greater than the quadratic, which is wrong. But this is right. The quadratic itself is right, and this first inequality is right. But it's just, I think this inequality is the wrong way around. And let's go to the next question. This is just a logarithm question. They didn't give you any like previous parts, which means that it's a bit more difficult. But anyway, I think you should be able to handle it. So you can move the 2 over, and you can move the 5 to the other side. You could say that 2 is just log base 5 of 25, and then you multiply, and you combine the log base 5x and log base 5 25 to just get log base 5 25x, and then you can cancel the logs. I kind of just did that in my head in one step, but you don't. There's no pressure on having to write it on the page. And then you just quadratic stuff. There's another quadratic. It's nothing different. And then for this solution, you just say that when x is a ninth, this log will be negative, which means it's wrong because you can't have negative logs. And that's the solution, x equals 4. Question 10, we have some more corner geometry. It's beginning to look a little bit repetitive, which, if you haven't noticed already, these papers are quite repetitive. Show that this is the line equation, so it's just a perpendicular line. You do the perpendicular gradient. Pretty simple stuff. Then next, you find this area of the triangle ABC. So you have this equation of the line. You have both of the equations of the line. So I found this equation, and then you have a different equation of this line. Then you solve the simultaneous equations to find C, to get these coordinates. Then you can just do base times perpendicular height. You know from A to B is 18 because this is negative 10, 0, this is 8, 0, as it says here. And then you can find the other point by just substituting. Then you know that the perpendicular height is this, what we found here, because that's the y coordinate of C, and you just do base times perpendicular height over 2, and you get the answer. For the next question, I give you a lot of space for this, Jesus. Oh yeah, this is another model question. When it's first measured, this is the same as last time. You just substitute 0 into t. You can see this is very similar to the other model question we had in the last paper. So you just find that it's 0, so you just know that this is 2.3 minus 1.7. Then after 4 years it was first measured, it was growing 15 centimeters per year, which means that it's the rate of change of time. So you just differentiate. I explained how to do that in the last bit. Substitute the time thing in. This is exactly what we did last paper, and it's in centimeters. So it's asking you to show that it's 15.3 centimeters, not 0.153 meters. So you just convert it. Then, according to the model, there's a limit that it can grow. Well, that's just 2.3, because that's the top bit, and then you're minusing all this graph here. So the limit. If you think about this graph, it just looks like this, and then plateaus at 2.3. So that's the apparent limit to this model, or to the plant, according to the model. Right. This question is interesting. This question is very interesting. So you have this first part's pretty easy. You just turn the tan into this, and then turn the cos squared into sine squared, get the quadratic, and then that gives you the answer. Then you solve. You do the quadratic stuff. You say that it can't be negative 1.547 because that's outside the range of sine. This is the solution, and then you find these two values of sine, of x, sorry. This is two pretty simple stuff. Then for C, though, you have to give the number of solutions in this period. So I think, if I remember correctly, I think I got the number of solutions. Did I get the number of solutions right? Because you have to say that, because in this range for this equation, there's 2 solutions. So if you multiply that range by 5, you get 10 solutions. And then because it's multiplied by 3 here, it's squished inwards by 3, which means those solutions become 3 times more solutions, which means there's 30 solutions. But I could be wrong. So don't take my word for it. But that's kind of my I think that's the thought process behind this answer. But there might be some extra solutions that I haven't remembered. Next question, we have some more vectors, so this is again not very important. So you just find AB, this is the same as last time, you just put the vectors together. Find mod AB, again, literally the same as last paper, you do the Pythagoras. Then this is an interesting question actually. I kind of just completely guessed this last part and got it right. But anyway, we're finding the value of P here for C, given that they lie on a straight line. Well, remember from GCSE, when vectors lie on a straight line, they have a scalar of each other. And so therefore this means that you know AB, but that means you know AC must you know that this is negative 2i, so you can find AC by just going from 10 to negative 2. That's negative 12i. But you know that the scalar for you know that J must be P plus 3, because that's just from A to C. And you know that therefore you can just say that you can just use this to solve for P, because there's a scalar that you know that P plus 3 must be a scalar of 12, because you know the scalar is 2/3, because going from negative 18 to negative 12 is just 2/3. So p plus 3 must just be 2/3 of that value, which means that you just do that, you get p equals 5. Then for the next part, I kind of just drew the triangle out, and because the scale is 2/3, I kind of just guessed. I didn't expect to get this right because I haven't formally covered this in class, so I've just kind of done it in my own time slightly. So I haven't really covered it that much myself. So I kind of just said it looks like 2/3, and the scalar is 2/3. So I just said that it's 2/3 to 1, which is right. So I think there's probably an easier way to prove this, or no, a way to prove this. I didn't really prove it at all. But anyway, let's go to the next question. More binomial expansion. Find the coefficient of x to the 5. What we need. Unlike the last question, there's no shenanigans with the fraction and the different terms. So you just know that this is the x cubed term of this, and then there's obviously only one x squared term of this. And you can just say that you can either use the x squared term of this and the x cubed term of this, or you can use the nothing term of this and the x to the 5 term of this, as you can see I've done here. So I've just done the choose function in my head here, or not in my head, but I just kind of remembered the Pascal's triangle physics from GCSE further. So you can use the choose function if you want. And I've just expanded with this. I haven't included any x's. I just done -1/2 instead of -1/2 x because it doesn't matter, because we know there's x to the 5 and we're finding the coefficient. We're not finding the actual x to the 5 term. And then you just add all these values together. You get this. And that's your answer. Next question. Verify that x equals 1. Oh my god. Verify that x equals 1 when they intersect, which is one of the intersection points. You set them equal to each other, put x equals 1 in, and they equal the same thing. Next question, they also intersect at x equals k. And given that k equals 0, use algebra to find the exact value of k. So this is a sneaky way of them adding factor theorem into the paper. So what you do is obviously you've set these equal to each other already, but you have to rearrange this to get a cubic that equals 0. You already know that x minus 1 is one of the factors because x equals 1. So that's one of the solutions, therefore x minus 1 is a factor. Because if you think about it, when 3 equals 3 here, if you were to take this away from each other, it's just 3 minus 3, which is 0. So if you substitute x equals -1 to this, if you substitute x equals 1 to this, it will give you 0, which means that x minus 1 is a factor. Which means you can just do the algebraic division however you want to do it. You get the quadratic, and finding the exact value of k, it says k is less than 0, which means it's the 2 minus root 10, because you have 2 plus minus root 10, but it's only the minus because k is less than 0. Alright, I think it's the last question. No, it isn't. We have another one after this. So we need to find find f of x. We know that it gives us f dash of x, which is useful. You can integrate this to give you this in terms of a and b, and you know that the c is -5, so you don't need to do a plus c for the integration. It's just -5 because it meets the y-axis at -5. That is the constant. Next, you know it as a stationary point at 4, 3. So what you can do, you can just set this, what I did at the top here. You can set this f dash of x that it gives you here to 0, and then you can use that later. You can set f dash of x to 0 and then substitute 4 into the x's. They give you this coordinate just to, well, they give it because it's useful, but also it kind of throws you off because you don't use it when you're using the stationary points. You only use the x coordinate. And then you can substitute 4, 3 into the main equation because 4, 3 is just a point on the graph. And then you can solve these simultaneous equations here. This one here from the stationary point, and this one here from just the point that you substitute into the main equation after you integrate. And you get this here, and you just get this. I'm sure you know how to solve simultaneous equations, and then you substitute that back into the integrated expression because you've gone from f dash to f by integrating. And that will give you your answer of f of x. So next question. This is, so firstly, you get a counterexample. This is easy. You just kind of like half of the numbers will work here. It says that prove that this is a multiple of 8. What I did this, I overcomplicated this in 2 different ways. So Firstly, I didn't see that it said consecutive even integers, so I just said that they were two different even integers, because it does work. Any two even integers that like this are a multiple of 8, but it asked you for consecutive, which in the mark scheme it does say you can actually just use two even integers. But also I used the difference of two cubes, which is this. It just made it infinitely more complicated. So what you can do is you can just say that so the thing you're supposed to do is you're supposed to say that Q is 2k and P is 2k plus 2, and then you substitute them in and you factorize 8 out. That'll give you or I think it doesn't instantly give you 8, but eventually you'll get there. Or what you could do, which actually makes it a lot easier, is you could say that one of them is 2a and one of them is 2b, which are two different even numbers, and then you can just factorize 8 out of that instantly. But what I did is I factorized like this, and then sec 2a, 2b, and then factorized 8 out like this. But I basically just substituted 2a and 2b into the equation, but I just did it in a fancy way. And then I realized later on that it's consecutive, like in the question, but then I couldn't be bothered to write out a new proof. So I just said that any two numbers automatically, like, assuming that two numbers could be consecutive, like if any two even numbers are like this are multiples of 8, then two consecutive even numbers must be like that, because we've just proved that. But anyway, you see we have a theme here of me overcomplicating the proof questions, but there's a very thorough mark scheme for proof questions, because there's a lot of different ways to prove stuff. So next we'll go to the last paper. My voice hopefully will stay awake for this last paper, but we'll see. First question, again, this is going to be incredibly similar. We have another integral. I'm not going to go through it. It's just an integral. You do the powers. I don't know how this is 4 marks. You remember the plus c. Next question, factor theorem, just substitute 4 into the expression. Find these things. Then express... Oh, sorry, no. So I've said A that this is... I've shown that this is the thing. Then part B, I didn't actually write B. But part B, it tells you that... Right, sorry, I'm just refiguring out how I did this. It says given that x minus 2 is a factor, I've expressed this in the form. Alright, so what you can actually do here is you can just... you don't need to... This is actually really easy, because you can find... So you find A, right? So you substitute -2 into this thing again. You solve the simultaneous equations. You see that this last term is 24. And so you don't have to do any division here. You just see that this last term is 24 because A equals 3. And you say, well, you're going -4, -2, that gives you 8. To go from 8 to 24, you need 3. Jesus, you need 3. So now this term, the K must just be 3, because that's the only way that this is going to become 24, which it needs to be. Next, with stating the number of real roots of this equation, you should say it's 3 because these are all real roots. You can factorize it into 3 different factors, so therefore there's 3 real roots. And then write the largest root of this equation here. So you're just, it's obviously not going to be 2x plus k, because that's a negative root. It can't be, and then so it's therefore going to be x equals 4 is the largest root. And you just multiply that value by 3, because you're doing the opposite of whatever's in the bracket. And it just gives you x equals 12. You don't need to write like 12, 0. Alright, next question. We have some more vectors, which is amazing. I love doing vectors. I do not like doing vectors. So again, oh wow, common thing between these vectors questions, find PQ. Wow, so you just do the same thing we did last time, where how do you go from 9 to 3, you minus 6. How do you go from -8 to -5? You add 3. You're showing that this value is 90 degrees. The best way to think of doing this is just finding the distance between all of these vectors and just showing that showing that Pythagoras works on them. And it's probably a way I think you can use dot products for this when we learn it. Or if you're a single student, good luck. Jesus. Yeah. If you're a single student, good luck, because you're not going to learn dot products. But and next we have this here. So find the exact area of this thing. So I've wrote all the points like in a graph like this. You know that S is on a point where PS is 3QR, which doesn't really make much sense, but you can just say that you've already got all of this stuff here, and you can just say that you can find all of this stuff here by just subtracting the vectors from each other, and then modulusing and then doing Pythagoras, and then you can use you can just, you know, it's a right angle triangle, so because this, it's just because these are on a straight line, it's not actually a square. I don't know why I said that. Because QRS are on a line, therefore it's just a triangle, and it's a right angle triangle because we already proved that PQR is 90 degrees, therefore PQRS, or PQS also must be 90 degrees, because it's just a scalar of this line. And then we can just do all the modular stuff, and then find the area using half base times height or whatever. Again, don't worry if you don't know how to do this question because we haven't done it in class yet. So, next question, we have some trig. Show that x is 10.5. It tells you that these angles, you just have to use, I use sine rule. Yeah, I use sine rule. You know that sine 30 is a half, so dividing by sine 30 is just multiplying by 2. You simplify, blah, blah, blah. You get this. Next question. Given that AD is this, it tells you that, oh my god. Yeah, my voice is not having fun. It tells you this stuff. Find the length of AB. It's cosine, I don't even know what to say, it's just cosine rule. Oh my god. We need to get some water soon, Jesus. It's just cosine rule. Yeah. It's not looking good. It's just cosine rule. Multiply this angle by what? Subtract 180 from 150 from this angle. You get this. Do cosine rule. There you go. Every single time I say cosine rule, I'm always going, what is this? And you find AB by using cosine rule. Next question. Oh, they love doing these in AS papers for some reason, where you find, it's like reciprocal graphs, and you have to find these equations of the asymptotes. Sketch this, easy stuff. Do the coordinate interceptions, whatever. Part B, show that they intersect, set them equal to each other, multiply by x. Then it does the exact same thing as the last paper where it says, oh, given that one of these is the points of intersection, use algebra to find this. Well, you know that this is one of the factors, 3x plus 2, since x minus 2/3 is or minus 2/3 is the solution, so therefore this is a factor. You divide, blah, 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 do all the factor theorem stuff, and then there's your solutions. Next question, you have this weird binomial expansion with to the 12 for some reason. Show that a is negative 5/8, where it gives you the first term, so you just say that 12a is, because was 12ax is the first term, so you just 12a equals negative 15/2, find a, blah, blah, blah. Find the value of k. You know that 12 to 2 times negative 5/8 squared, which is just a squared, equals k, which is the coefficient of x squared. So you find that. And then then you have to estimate the value of 17/16 to the power of 12. So you set 1 minus 5/8 equal to 17/16. Find x, so that's what you substitute. Then you substitute 1/16 into your thing here, and then that's your negative 1/10 into your thing here. That's your approximation. Next question. Oh god, we have to do this. So this is another one of these graph things where it's in terms of x and log base p, log base p, log base 10 of p. I'm actually going crazy. So this question's using log base 10 of p equals mx plus c, because it's not log base 10 of x, it's just x, and you substitute these points in. You get this here. This is your equation because it gives you 2 points. You can find the line, and then you raise both to the power of 10 like last time. Or no, you raise both to the power of themselves with base 10 to do this. And then interpret the value of AB is just P when... Oh, wait, what the hell have I done here? I've just realised I've done this completely wrong. just completely ignore this question. We haven't actually done it in class, so I kind of just completely messed this question up. I remember I just realised I got 0 out of 5 on it, so just completely ignore this. I'm just going to move on. We're going to do it in class in a few weeks anyway, so don't worry. Next question, integration. Wow. Show using calculus that a is 2 is a turning point, so you differentiate, set to 0, get x equals 2. B, verify that the x coordinate. So whenever it says verify, you can just it's a show that question, except you can actually use the values that in the show that question that it gives you. So you just substitute -4 into this equation, and then and you just say that you said substitute into the quadratic, substitute into the line, and then they're both the same, therefore it intersects. Then show that the area, so this is actually quite generous, it gives you the area that it wants to show. So you just find this big, you find this trapezium here, which is 54, do some coordinate geometry, and then integrate, subtract 54, subtract the trapezium, that gives you the answer. Right, next, I remember this log question. I do not know what I was doing. So first few parts are really easy. First part, this is just 2p because it's 16 squared. B is just p over 2 plus q because it's 25 multiplied by 4, which is just half. It's log base a of 25 plus log base a of 16. No, plus log base a of 4, which is just half log base a of 16. So you can get that stuff. For this question, you know that 80 is p plus q over 2. That's an easy one because q over 2 is just 5. No, sorry, q over 2 is just log base a of... q over 2 is log base a of 5. And plus p, that's just log base a of 5 plus log base a of 16 is log base a of 80. And then for this part, I didn't really know what I was doing. And that's going to stay an unsolved mystery because I forgot to look at the mark scheme before the video. So, next question. Show that this is true. You just do that. I couldn't find a way to use my tangent to circle method where you just substitute the point in and it gives you the tangent. So I had to do the normal way where you find the perpendicular gradient. So it's -1 over the gradient of PQ equals 2 or -2. And then you do all the rearranging, get this, and then that's your answer. And then find an equation for C. So you solve this K thing, you find K, find the distances, that's the radius, and then you already have the center because it gives you the center, or it gives you just substitute K to find the other point of the center. And then you find the distance of PQ, which you can already find because, yeah, you can just find it. It gives you the point Q, so you don't even need to find the point Q. So you could just find this point, find the distance between them, square it, and then that's your value of this. That's R squared. And that is your equation of C. Next question. This is a bit of a weird question, I remember. So you get 2 different exponential models. So firstly, this is just an easy one, given that VB equals 2VA when t equals 0. Substitute t equals 0 for both of them. And that's your answer. For B, when the rate of increase is equal to the rate of decrease, I don't know how did I get something wrong here. Well, I know what I was doing anyway because I only lost 1 mark. So the rate of increase is equal to the rate of decrease, which means that which all that means is that when you differentiate, it's the same. When t equals big T, so we're finding the time when that happens. So you find you differentiate both. The way you differentiate between them, that's really confusing. The way that you know which one's which is that you just put dVA over dt and then dVB over dt just to see which one's which, and then you know that they equal to each other, and then you solve. I don't really know what I did wrong here, but anyway. But this is the right idea. You can check in the mark scheme. I've already had enough by this point because I've gone through 3 papers. Next question, we have some optimization again. It's just so repetitive every single paper. So you find the equation in terms of x and y of the total surface area, divide, get this equation for y, then find the perimeter in terms of x and y as well, substitute y into here, and then eventually everything combines because the pi cancels because pi x is like that. The pi x, you multiply it by 2, you multiply it by x, and you get 400 minus pi x squared plus pi x squared over 2x. So the pi x squared cancel out, and you get what it asks you to get. And then next question, and then this is just optimization, so all the first two is B and C are both just normal stuff. So you differentiate, set it to 0, find x, differentiate again, substitute in, it's greater than 0, therefore it's a minimum. Then determine according to the model whether the swimming pool minimum would be suitable. And it tells, so what it's asking is AB needs to be at least 1 meter, therefore Y must be around or at least 1. So if you substitute 10 into this original equation we got up back here, finding Y in terms of X, you get that Y would be 1.07, which is greater than 1. Therefore, this would, for the first time ever in a A-level math paper, when it asks you to do something according to a model, or like, is the model good, is actually, yes, the model is good here. Because Y is greater than 1, so you can say that, yeah, the model does work. The next question, we have some more tricks. So this is some more stuff. So you just expand, and then you, this is the difficult part. So the annoying part, not even really difficult. You just divide both sides by cos squared to get everything, because it tells you here that you need everything in tan. So you just, how do you get from sine squared to tan squared? You divide by cos squared, and then bring everything to this side. What the hell have I done here? Oh yeah, so you say that 7 tan squared is 3 tan squared plus 4 tan squared. So you like help this this minus 4 over cos squared isn't very happy because it has a cos in it and not tan. So you help it out by giving it some tan squareds to because tan squared is just, so 4 tan squared is just 4 sine squared over cos squared, which means that it will turn from 4 over cos squared to 4 plus sine squared over cos squared, yeah. Not 4 plus sine squared, what am I talking about? 4 minus sine squared over sine squared, sorry. And then the cos squareds cancel out and you get this stuff. Next question, I'm just reconsidering my will to do this video. Even though I don't think anyone's going to really be here for this part. So if you are, thanks. Next question, we have part B, solve. Oh, this is just set it equal to 4. Oh wait, no, you're just solving, so you just find the values of tan and solve, blah blah blah, get your values. And then for the next part, I kind of just didn't see this part. So, yeah, find the smallest, wait, I'm just looking at it now for the first time because I kind of just skipped it when I was doing the paper, I didn't actually see it. So, find the smallest solution in that range, which is the same equation, so it's this equation here, because it's 4 alpha instead of alpha. If you multiply this range by 4, it would be, you just multiply all these solutions by 4, and if any of them are above 720, all the ones that are above 720 you group together, and you find the smallest one out of those ones. So you multiply each of these solutions by 4, find the smallest one that is also greater than 720, and then that's your answer. Next question. Prove using algebra. I think this is the last question, thank God. So I don't think I overcomplicated this one, actually. I'm quite happy with myself here. Maybe I did, I don't know. I think you can just say that n plus 5 is even because it is. But anyway, so this is just proof by exhaustion. But it does say proof using algebra, but exhaustion kind of counts as algebra, kind of, because I factorized, so that kind of counts as algebra. So case 1 n is odd. This is in the mark scheme, by the way, the proof by exhaustion, so it does work. So case 1 n is odd, substitute 2n plus 1, you get this stuff here. And yeah, that gives you this, and you factorize 2 out, therefore it's even. Then case 2n is even, substitute 2k, then that literally already gives you the 2, because there's 2k on the outside, you don't even need to expand this. And then therefore, because they're both have multiples. In both cases, the multiples are 2, therefore 2 is a factor. Therefore, it's even. Done. Thanks for watching. If you skip to the end, you can watch back, because I think I had at least 20 voice cracks this video, so good luck finding all of them. See you next time.